Hey everyone, I'm Amanda with DevExpress and welcome to Developer Tools Build versus Buy ROI Calculations for Third-Party Tools presented by Forrester Research Principal Analyst Mr. Jeffrey Hammond. Jeffrey serves application development and delivery professionals. He is a leading expert on open source software, next-generation mobile, open web, and client architectures, and improving software development productivity. Jeffrey is starting his 6th year at Forrester, and in 2009 was named the top industry analyst covering development by the Institute of Industry Analyst Relations. DevExpress commissioned a study by Forrester to investigate the question, is it more cost-effective to build tools and components on your own or to purchase them? And to track the return on investment, or ROI, an average company realized when implementing tools. In this webinar, Jeffrey will walk you through an ROI calculation model and help you consider how you might evaluate your future tools investments. There will be time for a Q&A session at the end of this presentation, so please enter your questions at any time in the questions section of your GoToWebinar control panel. Now, before we get started, DevExpress would love to know a little bit more about all of you joining us today, so we do have a couple of poll questions for you, and the first one is, are you currently using third-party controls? You can select one of the following. Yes, I'm a DevExpress customer. No, you're currently evaluating tools. Or yes, and you're using competitor tools. So you can choose one of the following, and I'll give everybody a second to get their answers in. Great, so it looks like about 72% yes, are using third-party controls and are a DevExpress customer. 11% is no, and 5% currently evaluating tools. Great, and our next poll question is, have you done an ROI assessment on tools before? And again, you can select one of the following. This one's easy, yes or no, and I'll give you just another second to get those answers in. So it looks like about 75% no, 25% have done an ROI assessment previously. Great. And then here's our third question. Are you the decision maker regarding tools purchasing? Again, select one of the following, yes or no. Are you the decision maker regarding tools purchasing? 73% yes, and 29% no. Great. All right, everybody, thank you so much for your valuable feedback. And again, thank you so much for joining us. I will now hand things over to Mr. Jeffrey Hammond.
Thanks a lot, Amanda. So, it's an age-old question. It's, not necessarily which came first, the chicken or the egg, but, I need to accomplish a task. And should I look to buy a solution to accomplish that task, or is it just easier and less painful to build a solution to implement that task from scratch? Now, as developers, I think we tend to look a certain way when it comes to buy versus build. But there are a lot of drivers to consider. So some of the things that we look at, from a build perspective, when I build something, I have complete ownership of it. I can do whatever I want to. I retain the license rights to that. And unless it's something where somebody else has filed a patent, I also have the IP ownership to that. And I might even have it in the case where there is a patent as long as I have prior invention. That tends to be a little bit of an economic benefit or a driver to go custom, because when I buy something, my ownership rights are very much dependent on the type of license. Now, I spend a fair amount of time in the open source world as well, so sometimes those licenses can be fairly permissive. But for most of the products that we see folks buy, the licenses are commercial in nature, and so there are restrictions on how the source code can be used. Another pro for build is that when I build something, I can take a look at my requirements and I can exactly match what I build to the requirements for its operation. And unfortunately, when you buy a product, it's not always 100% fit. Sometimes it does more than what you need, and you can get into a situation where you're hitting a sledgehammer or hitting a nail with a sledgehammer. Other times it doesn't quite fit what you need, and so then the question is, well, do we adjust the requirements to fit the capabilities, or do we look for a way to extend what we buy to really adequately support our needs? Another reason that you might build is that if you've got the source code, it's pretty easy to fix defects basically as quickly as you can line up the resources to take a look at those problems, whereas when you buy a solution, it's often dependent on vendor support. On the buy side, the biggest reason that we tend to find people buying components are that in terms of deploying those components, in terms of testing them for functionality, it almost always tends to be quicker to deploy a purchased solution, a pre-built solution, than writing something from scratch. If you don't have it, it takes time to write it to figure out what you're going to do. Now, in between these reasons to build and reasons to buy, there are some factors that aren't always clear, and you really have to take a look at these factors in making the overall decision for build versus buy. From a time perspective, if you have to write something from scratch and your business needs a solution within 3 months, that could really be an inhibitor toward custom development. On the other hand, depending on what kind of business you work in, it could take 6 to 8 weeks or more to get the purchase order through purchasing and to get the sign-off from a management perspective, especially if the solution costs a lot of money. So, it's not really clear whether, you can get something out that's custom or get something through the purchasing department unless you're in a small organization or in an organization where generally the purchasing department tends to have streamlined processes and supports you well. From a maintenance and support perspective, if you are simply buying and deploying as built by that commercial product, generally support costs are going to be lower. But if you have to maintain, extend something that you've bought to make it fit the requirements, you're also going to incur maintenance costs even as in a situation when you buy a component. So it's not always clear which side from a support perspective a build versus buy decision falls on. From a capital perspective, building versus buying is fairly different. Is pretty different. When you build a solution, there's probably not going to be a lot of capital costs because you're writing the code from scratch. You're essentially trading capital costs, CapEx, for labor, for operating expenses, because you've got developers that have to write the code. On the other hand, if you spend a lot of time writing something and your devs are fairly expensive, and for many of us that's the case, then the operating costs pretty quickly overwhelm the capital costs that you might expend. The final thing, it's a little bit intangible, but we're developers. We actually like to write code. It's what we do. It's always fun to have ownership over something, at least at the start, and have complete creative control over what you're building. On the other hand, any of us that have ever tried to maintain somebody else's custom project that they've built, and we come in after the fact, and maybe it wasn't well commented, and maybe there's not automated test case, know that the fun tends to go away after the first or second release, and that's where having somebody else maintain that code base, have the value of that code base shared across multiple organizations, tends to reduce the cost of those unpleasant maintenance and further extension tasks. So it's kind of in the realm of this overall set of drivers that we want to take a look at the component market in particular, and that we looked at some of the products that DevExpress makes available to developers. So what I'd like to do is talk to you about how we look at the economics of this build versus buy decision in that context. So at Forrester, we have a framework that we call the Total Economic Impact Framework. And it's a little bit more complex than a simple ROI calculation. In a simple return on investment calculation, what you tend to look at is the benefits, essentially the return that a solution provides. And you look at the costs that solution incurs. So the first two elements of the TEI framework, the impact on the budget and the impact on business. Now to that, we add two additional considerations when you're looking at the overall benefit that using a particular product might have. The first of these is flexibility. In the financial space, there's this idea of options, and you can value options. When I was studying finance, we used Black-Scholes as one of the common ways that we would calculate the value of options. You also have to take a look at risk. What are the range of potential outcomes? what would happen if the implementation turned out to be a disaster. We've all read about projects where people are implementing CRM systems or supply chain management systems, and the project goes horribly wrong, and they spend millions of dollars, and they can't actually implement the system as it was designed. So you have to take a look at what's the probability of a better than expected outcome, what's the probability of a worse than expected outcome, and based on that range of risks, calculate an estimated average outcome to adjust the potential costs and benefits. When you put all four of those aspects together, that gives you what we call the total economic impact of a decision. So that flexibility, that options perspective is very important. So for example, in a tactical solution, if I implement a grid control, then that grid control works for that solution. But if the grid control that I pick also opens me up to potentially port to additional platforms, that creates an option down the road that I think I might need to exercise. And that option has a discrete value. In another situation, if I implement a packaged application and I implement one module, but it's part of about 10 different modules, and I might at some point decide that I want to implement those other modules because I'm going to get additional benefit from them, that modularity and that integrated capability that that overall solution has gives me an option value. So we need to look at those options because a lot of times that can help tip the decision one way or another when the tactical differences between a buy or build decision are actually fairly small. So when we take a look at a particular buying decision, we apply this TEI framework, and we do it with a specific use case, a specific business study. We don't do it in the abstract. So in order to do that, we work with a user of that product, and we understand how they're using the product. We do that by conducting extensive interviews with them, and in this case, we had a number of interviews with a large multinational financial services organization. Based on that, we build a financial model, do a fair amount of modeling in Excel. We validate that model with the case study, and we identify the points at which the inputs to that model vary. And from there, we write up a case study that documents the model, looks at the specific benefits. Now, that case study is usually delivered in a Word document with an Excel spreadsheet. I'm not going to go through those items today. I'm going to summarize the results. But those items and that calculator to help you look at your own potential situation is available from DevExpress. And if you're interested in putting together a TEI impact that is specific to your organization, I'd encourage you to reach out to the DevExpress folks, and they'd be happy to put that in your hands. So with that, I'd like to review the specific case study that we looked at. Again, it's a large multinational financial services organization serving lots and lots of internal employees with the specific products that they implemented. So basically, in their situation, we focused on a single control that was part of the overall DevExpress DXV2 offerings. And in this case, it was the DX2 grid. If you're not familiar with the grid, it offers a lot of flexible capabilities to display information in a tabular format in a variety of different ways. Now, this was an interesting situation because it wasn't necessarily a straight, build from scratch or buy, drop in, and go decision. In this case, the case study actually took that grid control and fairly extensively modified it. Now, why did they do that? In their situation, they were building an application for traders that required a lot of information to be assimilated and made available very, very quickly, so low latency demands, and also a tremendous amount of information needed to be available in the grid at a single point in time. And so when they went out to figure out how they were going to do this particular thing, they thought about building from scratch because of their particular needs. They took a look at several different companies in the control space and their grid capabilities, and the stock grids really didn't satisfy what they needed to do 100%. So it goes back to that fit for requirements not being there. But what they found with the DirectExpress grid was that the customizability and the flexibility of the grid was such that they could essentially buy and modify. And so this particular case study and the particular drivers and the overall total economic impact is influenced by the fact that they took this and did some fairly substantial modifications to it. So what really represents a hybrid case, and actually a fairly common case that we see when development teams use third-party controls. So in this situation, the traders demanded high usability, so that was an important part of the decision-making factor, maybe something that wasn't a direct economic calculation. And again, that DX2 grid helped the team deliver on those usability demands. So with the TEI framework, the first thing that we look at is, well, what are the benefits that you got from using the product? There were two primary benefits that we saw in this case. The largest of those benefits from an economic perspective was the value that they got out of reusing the code compared to what it would have cost them to write an equivalent piece of functionality from scratch. The team that we talked to felt that they easily saved at least 6 man-months of development just by using the DXV2 grid control in this particular application on a single application. Based on the average loaded cost of their development talent, and they happen to be on one of the coasts, so we know that dev talent on the coast tends to be a little bit expensive. We usually estimate about $200,000 a year for a fully loaded developer. That's the salary plus benefits plus stock options. That's a pretty good rule of thumb if you're on the East Coast or West Coast. At 6 man-months of effort, that it would have cost them about $100,000 to write the version 1 from scratch compared to what they actually built. Now, the secondary benefit that they got beyond the code reuse was a reduction in the amount of maintenance and QA that they have to do. Now, their situation was interesting because they did extensively modify the control. They still had some maintenance that they had to perform on the parts that they built on top of the core piece. But the control itself, when they got it from DevExpress, it had already been pre-tested in its basic configuration, and there were about 4,000 test cases that DevExpress uses every time they run a test regression to update the control. Now, in DevExpress's case, those test cases are automated, and to run all the cases across all the different platforms and evaluate the results and make sure that they all pass takes about 10 hours per 1,000 test cases every time they do a release. So if you take that 10 hours of tester time over 4 releases per year and look at the average loaded cost of a tester, that equates to about $15,000 a year in savings in basic testing of the code that's in the control that they adapted. So over a 3-year period, that works out to about $46,000 in direct benefits from reduced testing costs. Now, from a variation standpoint, you might take a look at $96 an hour and say, boy, that's awfully high for the cost of a tester. If we outsourced all of our testing to a third, an offshore organization like India or Brazil or one of those places, we could probably cut those testing costs to maybe $25 an hour. And if that's the case, then take the calculator and plug that sort of estimate in. The one thing that I would say is that you would also need to factor in the cost of developing those regression test cases yourself if you were to build your own controls. We looked at that as a sunk cost in the case of this TEI, so we didn't include that in terms of the overall cost analysis because that's just a sunk cost that DevExpress has taken on as part of their QA effort. But it is something that you would need to factor into the model if you were going to change it and look at the potential costs of doing it yourself. So, primary benefits that we saw. The costs. From a cost perspective, obviously there is a license fee cost. Now, in this particular case study, the client has an enterprise license fee, so there's a number of devs in their organization that have the entire DevX suite, not just the grid, but all the other components. And when we looked at the number of developers that were supported across the organization compared to the number of devs on this individual team, we prorated the overall enterprise license cost based on the fact that there were 2 devs on this particular team. And so if you look at the yearly license cost, the year 1 license cost for the entire DX suite that they were using were about $7,000, and that includes the first year of support, and then there was ongoing support. So that looks at the overall total in terms of licensing fees at about $3,000 per year. We also factored in an implementation and learning curve. If you're looking at code that's not your own, it's going to take a little bit of time to come up to speed, look at the documentation, understand how the documentation works, figure out how much of the code you can use as is, where you might need to modify it. In this particular case study, the developers told us it took them about 3 weeks to really get proficient, understand all the ins and the outs of the grid, and be able to start moving forward and customizing around what they had built. So again, if you look at the average cost of the developers at the 200K level, that 3 weeks equates out to about a one-time cost of $11,000 in terms of implementation and spin-up. The other thing that we saw then was the cost that they had to adapt the code to the organization's needs. That was about $30,000. If you were just dropping in the grid and using it, in your situation, you would not have this cost. It would probably be closer to 0 for you. But in this case, since they did some modification, that was part of the overall equation. We also added in maintenance costs because this particular case study built and modified. They figured that they had about 4 hours a week ongoing that they spent maintaining the code that they had built to extend the grid, to replace the model that they had put underneath it. And so over a 3-year period, we had to factor in those maintenance costs as well. So total, what that worked out to was an average cost per year of about $23,000. Now, from a flexibility standpoint, some of the things that we looked at, and the key thing that you need to look at here is the modification of core function. There are 2 ways in the DevExpress situation that you can modify the code that you buy. In the case of our case study, they didn't actually have to look at the source code. They were able to modify the control grid and the framework that it has itself through using the APIs that are provided by the grid control. So everything that they did was doable without having to crack open the core source code that DevExpress provides, which has some really good options in terms of testability. If you're not maintaining that core source code, the 4,000 tests that DevExpress runs on a regular basis when they update the releases are not something that you have to look at and say, well, do we need to update these? Do we need to run our own tests to retest the functions that we have modified? The other option in terms of modifying and extending core function would be to actually tweak the source code itself. That was not used in this case, but the option that the source code was available does have additional value, even if it was not an option that needed to be exercised in this particular case. The componentized construction of the DXV2 framework also had an option value. You'll notice that they were mainly, in this case, using the grid framework. While they looked at using some of the other controls, and they'll probably eventually implement some of those controls at a certain point in time, with the initial launch of the product, the grid was all that they needed. So that was all that they put in. They didn't have to extend the amount of source code, the number of lines that were in the environment by using the other controls. That keeps the overall code base, tight. It reduces the threat surface from an application testing perspective. One of some of the other flexi points in this particular TEI, flexible deployment. So although the existing application is being deployed in-house, mainly to traders, if they wanted to deploy it to other users and potentially even customers in the future, there's not going to be a hit from a cost perspective in terms of licensing or maintenance costs. So they do have the option of potentially deploying this to partners or customers in the future. That has an option value. And then finally, looking at additional platforms. Primary application right now was released on top of Windows, was built in WPF, and that had a lot of value from a usability perspective. But in the future, if they want to do Win8 tablets and maybe shift over to WinRT or move to other devices, maybe even an iPad or something like that, the migration path to something like DXtreme is also an option that is part of the overall economic impact. From a risk perspective, when we talked to the project about what risks they associated with the project, we found that they were fairly low. Because there was a modular environment and we were really looking at one control, that risk from a size of the source base, from the difficulty of implementation was fairly low. From an implementation risk standpoint, it's possible that instead of 2 developers, they might have needed to bring a 3rd or a 4th developer on, which might have increased the cost of licensing the controls, but they ended up not needing to do that. It is also possible that it might have taken them longer than they expected to be able to spin up and learn the grid controls. So if you look at the variance there, instead of 3 weeks, it could be 4 weeks or 5 weeks. It could be as low as 2 weeks. But when you look at the overall cost from a developer perspective, you're talking a couple $1,000s there. You're not talking 10 or 20 or $100,000 of potential variance. From an impact risk perspective, there was substantial risk that if the grid didn't work, they would have to go back to square one. They'd have to go to another vendor. They'd have to go back to writing their own thing. But again, this demanding performance and display need, because of the capability to customize the control, was a risk that when they set out on the project they felt was relatively low. So overall, the case study participants judged the risk of implementing the DXV2 grid as low. And so when we modeled that, the way that we modeled it was, if you accept, everything goes as planned type of use case, you'd say that the project would meet 100% of targets. If you judge that the impact, the implementation risk, the impact risk of a particular project is low, you would typically adopt an outcome with some fairly narrow constraints. You'd say, okay, well, a best case scenario, we'll do maybe 2% better than the optimum. And in a worst case scenario, maybe it'll take us an extra week, or we might have to have another developer on for a little bit of time just to help with something complex. So maybe a 4% decline. If we judged a particular set of risks as high for a product, we might say, well, best case scenario, you might come in 10% under plan. Worst case scenario, you might come in 50% over budget. So in this case, we adopted kind of the yellow lines that you would see here in doing the risk-adjusted analysis of the benefits. So that made the range of outcomes fairly constrained. Now, one more point I'll say is, well, why do we have a lower upside and a larger downside? Well, the reality is most people, tend to overestimate their capabilities, tend to overestimate the projects that they're on and the components that they're using. So there's usually a little bit of built-in optimism when it comes to estimates, and so that's why we tend to model a larger downside as opposed to the upside when looking at a range of different outcomes. So when you put all of those factors together, the benefits, the costs, the flexibility options, and the risks, what we get for a 3-year outcome with the DX2 grid in this particular case study is a risk-adjusted, discounted, positive cash flow analysis of about $22,000, almost $23,000. So easily something that paid for itself in about 6 months of payback period. That payback would have been a lot shorter if it had just been a drop-in control and there wasn't the ongoing maintenance. So this is actually a fairly conservative case study, in my opinion, of the sorts of benefits that you would look to get from dropping in the DX grid. So if we go back to that build versus buy driver from the initial slide early on in the presentation, and how this particular case study performed from an ownership perspective, because the license options for the DevExpress control, the DevExpress control, was very flexible in terms of what it allowed them to do. That shifted the traditional benefit for build more toward the buy space, because buy and modify was possible in this case. Same sort of thing when we look at requirements versus fit for purpose, because you could do a build and modify. It shifted the balance of that, matching requirements toward buy, because the requirements could be extended with the base code itself. From a defect perspective, although this particular case study feels like they got very responsive support from DevExpress, and that they didn't feel like there was an issue, they still had to fix defects based on the modifications that they did. So there wasn't that big an adjustment there. And because they modified the base control, they found that they still had to do some of their own testing, and they still had to write some of their own code. So from a traditional build versus buy decision, there was maybe a little bit of a shift back toward the build space in that particular dimension. From a taking time to write versus a taking time to purchase perspective, they do feel like they saved a significant amount of time getting their solutions out and to their customers, and that was a net benefit in terms of taking the buy decision. From a support versus maintenance cost, again, because there was some modification and they did have some maintenance cost, maybe there was a little bit of a shift back toward build, but it wasn't really significant. From a capital cost perspective, as we saw, there was a fairly positive ROI and a low payback period of 6 months. And now, the operating costs overall are lower, certainly compared to the capital costs. And again, the benefits of the code that is shared, the code for the graphical representation of the grid, the code for the user interaction and the flexible capabilities, that tended to push the decision in this case toward the buy perspective. So clear decision. Buy worked in this case, certainly better than build, and the buy and modify was a home run. Now, there were some other considerations that were more than just about the TEI. The ability to have some of those really nice graphical features, sorting and grouping and filtering, was very valuable to the dev team. And the usability was something that they really felt was beneficial as well. And in the intangibles, if you will, the intangibles were clearly in favor of the buy decision in this case as well. So just to bring that to a close, build versus buy decision is not rocket science. You should look at the drivers, and you should assess those drivers in your own specific case. I would say that you really need to look at source availability and the ability to modify controls and components, because in reality, I think there are far more of these buy and modify type case studies than there are just drop in and go type situations. So it's not always just a build versus buy decision. That buy and modify decision is a really good middle road, and it can provide a good compromise if the product's supported, and it can still provide some pretty compelling positive results from a total economic impact. You need to make sure that you include the testing and maintenance costs into your analysis, both your own testing and the testing that is required from the control that you're using, because that is testing that if you go custom, you're going to have to replace yourself to tamp down the risks of poor implementations. I always ask this question of my clients: are you in the infrastructure business? Are you in the business of the basics, or are you in the business of supporting your business users? And in this case, it's pretty clear that this case study is in the business of supporting traders, not in the business of writing really great grids, even when they have to modify the grids to meet the needs of those traders. Make sure that you look at the option value of the solutions that you are taking advantage of, especially in the situation we're in now, where we're moving into a multi-channel world, multi-device, multi-platform. And because system life cycles are getting shorter at the same time, as we start to look at some of those devices, it's a real good time to think about your options in terms of cross-platform capabilities. Modularity is important, because the more modular the code, the lower the implementation risk, the lower the impact risk, so that's going to give you a better result. And finally, a buy and modify scenario can have a quick payback. Buying used, probably even better. We'd probably be looking at a 2-month payback period instead of a 6-month period, but still nonetheless fairly cut and dry case. So with that, I'd like to thank everybody for paying attention, and I'm happy to take questions.
Great, thank you so much, Jeffrey, for that presentation. I wanted to point out to everybody, Jeffrey mentioned this, but all attendees today will receive an email from us with a link to request more information and a personalized walkthrough of this ROI calculator. By clicking on the link and filling out the form, you'll be contacted by our enterprise sales team to schedule a one-on-one session. So just keep an eye out for that follow-up email from today's webinar. And if you do have any questions, which Jeffrey, we don't have any questions just yet. If you do have questions, please get them in now, and Jeffrey will answer away. And while we're waiting on that, I just also want to let everyone know you can visit DevExpress.com for all of our upcoming webinar sessions. We deliver sessions covering all platforms from beginning levels of training to in-depth expert webinars. And while you're on the site, if you haven't already, you can also download our universal trial at devexpress.com/trial. All right. Well, Jeffrey, no questions have come in, which must mean you were very thorough.
Either that, or the intricacies of net present value and ROI are something that are a little off-putting. But nonetheless, the calculator makes it a lot easier to do this yourself. So you can use the default values that are put in the calculator, or you can work with your finance folks, your purchasing folks, to adjust them based on your own figures. For example, if you're in the middle of the U.S., instead of an average loaded developer cost of $200,000, maybe you assume an average loaded developer cost of $150,000, and you see how that adjusts the numbers. If you are using offshore results, maybe you bump down the costs even further, and you see how that affects things. If you're not going to modify the controls, you just kind of want a basic grid or a nice a set of controls to use, then you knock down the maintenance costs, and you see how that affects the results.
We did have a question pop in. Is the offer for help with the calculator worldwide or domestic? Let's see.
Well, I certainly see no reason that you couldn't adjust it to fit any situation, even worldwide. So.
Okay, and yes, it is worldwide, just like Jeffrey said. Great question. All right. Well, I think with that, we can probably wrap it up. Thank you so much, Jeffrey, for being with us and presenting today. We really appreciate it.
It's my pleasure.
Awesome. And of course, thank you all for joining us. We hope that this was an enlightening presentation. And again, we want you to look out for that email and request your own personalized walkthrough of an ROI calculator if that's something that you're interested in doing. All right, everybody. Thank you again for joining us. Let's see what develops. Bye-bye.